Also, in the last class we talked about system of units, and we'll talk about scalars and vectors in this lecture. So the reason units were being introduced was to measure physical quantities, and these physical quantities, most of them can be broadly characterized as scalars or vectors. So physics means physical quantities. So physics, you see, they mean the same thing. And so after learning system of units, when we talk about the physical quantities at this level, physical quantities are broadly categorized as scalars or vectors. Now we talked about things like mass, length. So these are all physical quantities, but there are other physical quantities like pressure, velocity, density, volume, and most of these can be categorized as a scalar and vectors. Now what are scalar physical quantities? Well, physical quantities that need just a number to be expressed are called scalar physical quantities. For example, mass. So the chair I am sitting on has, let's say, 20 kilogram mass. So when you say chair weighs 20 kilograms, which is mass, do we really need to specify anything else? Well, no. It's just the number 20 that is required. Well, it can be 15 also, or it's 25. But the only thing that is required is this number. So mass is a scalar, and scalars are the physical quantities that just require a number. Let's take other examples. Let's say height. My height, let's say, is 1.8 meters. To express height, do I really need to specify something else other than 1.8? No, we don't. I really do not need to. So length is actually scalar. Similarly, let's say pressure. You might not be knowing, but the pressure at the surface of the earth is 10 to the power 5 pascals. Now again, pressure does not really require anything other than a number, which is 10 to the power 5 here. So pressure is a scalar. Other examples can be volume, area, density, work. All these actually are categorized as scalars. Now how do these scalars add up? Well, if you have one chair which is 20 kilograms, how much is going to be the mass of two chairs? Well, 20 plus 20, which is 40 kilograms. Or let's say if I am 1.8 meters tall, then what is the length of two people like me? So true length will be 1.8 plus 1.8 equals 3.6 meters, right? Let's say two volumes. Let's say if I have a plastic jar that can hold 1000 centimeter cube of fluid, which is volume, then how much volume can two plastic jars, please forgive my bad handwriting, can hold? Well, 1000 plus 1000, which is 2000 centimeter cubed. So what did we observe? We see that scalars are numbers, and when we want to add scalars, we just add them like numbers. So this is scalars, and these are numbers, and just add them like numbers. But there are other sets of physical quantities that actually need more than number. For example, let's say one example is force, right? Now let's say we know that we are able to apply some force using our hands. Let's say we punch someone. So when we punch someone, we are applying force on someone's face. But punching yourself and punching someone else is something different. Well, don't do that, but just for example, if you apply force like this, you punch someone else. But if you apply force like this, you punch yourself. Well, aren't they different? Yes, they are different. So force is something, well, let's say if you say I punched with a force of 30 Newton, that's a lot of force. But let's say I punched with a force of 30 newtons. But then whom did you punch? Your friend or yourself? It's not really clear. Force is not really being specified clearly. So force does not just need a number, but also needs the direction. You can see that's direction that also is required to express force. So you say 30 Newton away from me, or you can say 30 newtons. You say this is the east direction towards east. So your friend got hurt, but at least we understood our principle. So force is a vector, and all sorry, I should have told, and these physical quantities are called vectors, which require not just a number but also direction. Let's take another example. Let's say one more example is velocity. What is velocity? We have read that velocity is change in displacement divided by change in time. Now displacement is brother of distance, but displacements had a certain direction. For example, we can say the wind is blowing towards north with a velocity of 10 meters per second. Let's call this east, let's call this west, this is north, this is south. And to understand this, let's say you're driving a truck and you're going towards east, and you have a flag that is fluttering on top of the truck. Now if the wind, you might have observed that if you have a flag, and if there's a wind which is blowing towards the north direction, you will see that the flag flutters like this. But let's say instead you're traveling in the east direction, but the wind is in the south direction, then the flag will flutter like that. If you do not understand, that's alright, but these are two different cases. But if you just say that wind is blowing with 10 meters per second, you really cannot tell whether you're talking about this case or that case. So first of all, you have to specify how fast the wind is blowing, and then you have to tell which direction the wind is flowing. Only then you will be able to tell the direction of fluttering of the flag. So there are a class of physical units that just do not need a number, but also the direction in which they are acting, and these are called vector quantities or vector physical quantities. There are higher order quantities also, like tensor and so on, but we do not really have to talk about them right now. So basically most of the physical units can be specified as scalars, physical quantities that just need a number to be specified, and we also know how do we add them, just add them like numbers, and vector quantities that need a number as well as the direction to be specified completely. And we'll talk about how we add these physical quantities called vectors in the next lecture.